So we said a perpendicular bisector is a segment, ray, line, or plane that is perpendicular to a segment at its midpoint. And it cuts the segment into what? What did you guys fill in?
Two congruent parts.
Two congruent parts. Randall, where's your notes?
Can you find them?
I think are there. The ones that look like this.
Yeah, we're finishing it.
So yeah, I know we've gone through this part. We're gonna recap quickly. So it cuts it into two congruent parts. And in this picture, what was the perpendicular bisector of the segment?
PC.
Line PC was the perpendicular bisecting. It was what was doing the bisecting of segment AB. It was cutting segment AB in half, and it was perpendicular to it. Can a line be cut in half? No, lines have infinite length. Can a segment be cut in half? Yes, it has a set length, whatever that length may be. Is unknown to us, but it has a set length. And then we talked about this perpendicular bisector theorem because I said, hey, whenever we have something, we have to have theorems attached to it that we use. So, if the point is on the perpendicular bisector of a segment, then it is what we call equidistant. Remember those equal distances, equidistant from what? The two endpoints of the segment. So we said, hey, in this one, this far right example, I think is the one we looked at here. And so we said in that, since line CD is a perpendicular bisector segment AB, and since point C is on the perpendicular bisector, then it's going to be equidistant from the two endpoints. The distance to A and B are the same. Or if we continued on the bisector down here, because it's a line, and we had point O of W, for example, and we drew that here, the distance to A and B would be the same if I drew it better. Yes.
So something can't be in the middle of a line, but a line can be in the middle of something.
Correct. Because the lines don't have a middle. But segments have a middle. Yep. So then we said, hey, since this is written in if then form, that's something I'm going to highlight a lot as we continue to go on. If then form, we can also make the converse of it. In this case, the converse is also true. So we said we have the converse. If a point is equidistant from the endpoints of the segment, then it is on the perpendicular bisector of the segment. And we wrote this out longer and more full words, I believe, with bisector, but I'm shortening it up since we've already written it. So we said here, since XA, the measure of XA is the same length as the measure of XB, then X has to lie on this perpendicular bisector because it's equidistant from it. And so it must lie on the bisector of segment AB. So if we were to look at this and say, okay, well, let's suppose we had an extra point here. This point is not on the perpendicular bisector. And is this point going to be equal distances from A and B? No. It's obviously closer to which point? A. It's obviously closer to A than B, so it's not going to be equal distances like X is. So because it's not equal distances away, it's not equidistant to the points, it's not on the perpendicular bisector. Just like if I were to make a point here, it's not equidistant to each point, so it's not on the perpendicular bisector. Whereas if I make one way down here, as long as it's equidistant, it has to be on the bisector as it continues through, and I drew that really poorly. I drew that really poorly again, but I think you guys get the idea of this going through there. So if we continue on, so let's look at this example. It's not really an extra example. In fact, it's our first example. So it's just example one. In this diagram, left side of the page near the bottom, line RS is the perpendicular bisector of segment PQ. Find PR. So if it's the perpendicular bisector of segment PQ, that means that line RS is perpendicular to segment PQ, which means it intersects at a 90-degree angle. And what do we know about PS and SQ? What would they be if it's bisected? They'd be congruent, right? They'd be the same length. So wait, but we need to find PR. How does this help us find PR? Sophia, what are you thinking?
Isn't it if you have two of the same angles and then not two of the same angles? One that's congruent and then one that's like another one that's congruent because that's the line thing, right?
Well, those dashes mean congruent, yes.
Yeah. So if you have the sides that are congruent and then you have two angles that are congruent, couldn't it be angle sides theorem or?
We could. but we don't know that any other angles are congruent. And we can do this without triangle congruencies as well. We could do it with triangle congruencies. I like the way we're going back to that. We could do it with them. But we can also do it with something we just learned. Nick, what are you thinking?
Could be 6x equals 8x minus 9.
Okay, so what's your justification for saying that 6x is equal to 8x minus 9? What makes us be able to say that?
Bisector.
Okay, so this segment bisector, line RS is the segment bisector, R is on the bisector. If R is on the perpendicular bisector of the segment, if we look up right above this at the perpendicular bisector theorem, what happens if a point is on the perpendicular bisector of a segment? Then what? What's it say? Go ahead, read it. Everybody read it. Perpendicular bisector theorem. If a point is on the perpendicular bisector of the theorem, which R is,
Of a segment, not a theorem.
then it's equidistant from the endpoints of the segment. So is R the same distance from P and Q?
Yeah.
Yes. So what do we know about RP and RQ?
They're congruent.
They're congruent. If they're the same distance, the same length, then they're going to be congruent. So now can we know we need to set these equal to each other? Yes, we can. So we set it up and solve. So this was
Yeah.
right above here. So where it says theorem and it says perpendicular bisector theorem. This one, yes. So it was this part. So because it was on, thank you for asking. So because it's on the perpendicular bisector of the segment R is, we know it's equidistant from P and Q, the endpoints of that segment. So that tells us that we can set up this equation Nick told me. 6x is equal to 8x minus 9. Now is this an equation we know how to solve?
Yeah.
Yes, it is. It should be, because we've been doing this we did it all first semester, and you guys worked on it last year as well. So what would you do to solve this equation? Somebody tell me a good math move. So you wanted minus what? 8x. So subtract 8x. I don't see it normally. So if we subtract 8x, what's 6x minus 8x? Negative 2x equals negative 9. How would we solve now?
What if we divide by 9?
Divide by, we want to divide by negative 2 actually. We're going to divide, but think about this. What are we trying to get by itself? We're trying to get x by itself. We will end up getting a decimal. We'll get x is equal to, I heard it, 4.5, right? Are we given a label? No. Are we told just to find x? We're told to find PR. Thank you, Paige. Somebody was paying attention. Because a bunch of you guys just said, yeah, we weren't supposed to just find x. We were supposed to find PR. How do we find PR now? We found x, William.
We have to put it back in.
Put it back in. Into where?
In the PR.
Into PR, the 8x minus 9, right?
Yeah.
So let's put that back into there. So let's put 4.5 in for the x there. So we put that in. 8 times 4.5. That's going to be 36. Exactly right, thank you. Minus 9. So it is 27. So the measure of segment PR is 27. Now could we have plugged it in somewhere else too? We could have plugged it into 6x. Why could we have also plugged it into 6x? They're congruent. 6x is the same measure as 8x minus 9. What might have been a little easier to plug it into 6x?
Yeah.
So if we notice that, take advantage of it. Take advantage of that if you notice it. If you don't, we got the same answer either way, so it's okay. But if you notice those things, that's the kind of stuff that can save you work and save you time. Those are good things to notice. Questions on this first one? So this is applying that perpendicular bisector theorem, which we learned. If you look at the second example here, in the diagram, line JK is the perpendicular bisector of segment GH. So we have line JK, thank you. So line JK is the perpendicular bisector of segment GH. So we have perpendicular and we have it bisecting. So we're first have to ask this question, what segment lengths are equal? So who can tell me two segments that are congruent? Max, go ahead.
FG and FH.
Okay. So yep, we're told they're both 4.1, right? One is correct. No, it is correct. Yeah. Because we're told that they're both 4.1, right? So if they're 4.1, then they have to be that same length. So because we're told length, we know that segment FG is the segment FH. And so there's two others I'm looking for right now. There's two others I'm also looking for here.
I got it.
Okay, Randall, go ahead and give me one of them, please. One pair.
GK.
Okay?
And is that it?
Well, GK is congruent to,
There you go. You said only one.
well, there's two pairs, so I'm going to give you one pair.
HK.
So GK is congruent, segment GK is congruent to segment HK. So we're told that because segment GH is what is bisected at point K. And we also know one other pair of segments is congruent from this.
GJ and J and HJ.
How do you know segment GJ and segment HJ?
Because they made it a line. Yeah, that. I forgot what it's called.
So that's the same perpendicular bisector theorem we just did. Same one we did over here. So because R was on the perpendicular bisector of the segment, it's equidistant from P and Q. Because J is on the perpendicular bisector of this segment, it's equidistant from both G and H. So it's the same theorem we just used, same theorem we used on example 1 that tells us that GJ, segment GJ is congruent to segment JH. Because it's on the perpendicular bisector, it has to be the same distance there. So that's all we know for number 1.
Can't just do the bottom ones.
Okay, so let's go down to the next one. So on number 2 it says find GH. Find the measure of GH. How can we find the measure of GH here? Paige, go ahead. 2x equals x plus 1. They're congruent, so that tells us we can set them equal to each other. Very good. Nathan, what would you do to solve this?
Minus X.
Okay, I think it's a good math move. So you get just x is equal to 1. So we found x. Now what do we have to do to find GH? Lizzie, what would you do? Okay, 1 for the x. So I see a couple x's here, so do you have an x you want to plug it into? Into 2x? Okay, so we plug in into 2x, and we're going to find the length of GK. So we found that to be 2 here. Because 2 times 1, which is x, is just 2. Are we done yet? We got to plug into the other one because we need GH. We need to
Why
add
do we
them
have to plug
together.
it in if we know it's congruent?
Oh, that was a good question. Sophia said, do we need to plug it in if we know it's congruent?
Don't you add them?
We do, but what should this length be? 2, because it's congruent to this one. So this should also be a length of 2 here. And so the whole length will be 4. So the measure of segment GH is going to be 4. We could have plugged it in and taken 1 plus 1, which is 2, or we could say, wait, it should be 2 anyway. Questions on that? Okay, so the bottom of the page here, let's take our attention there. At these pictures, we have 4 different pictures of triangles here. AB there, there's my voice, is a perpendicular bisector in each of the following triangles. Each of these triangles is perpendicular and it bisects a side of the triangle. But what do we notice about these perpendicular bisectors compared to the ones that we've had so far? They seem off. How do they seem off?
They're not bisecting straight through the middle.
They're not going straight through the middle. Well, they're going through the middle of the segment. What aren't they going through the middle of? They're not even how? The sides. So it's not halfway between the entire triangle, like this one isn't going through the angle maybe. So before, we had this one going through right through the entire middle of the whole triangle. Whereas here, it's bisecting this segment still, and it's still perpendicular, but this time it's not going through kind of the center of the top of the triangle as well. It's only going through the center at the bottom. Or in here, the center on the top left, or here the center at the top, but not the center on both sides. So what we can gather here from this is, before you write all this down, is that the perpendicular bisector does not necessarily go through the vertex of the triangle. Vertex is where the 2 lines meet for the angle. So it doesn't have to go through this vertex like your other ones did. It can, but it doesn't have to. So what's a way you could summarize this in your own words if you didn't want to write all that out?
The bisector doesn't have to go through the middle.
Doesn't have to go through the middle, right? You could just write that, couldn't you? If you know, we're already talking about perpendicular bisectors, you could say it doesn't have to go through the middle, or it doesn't have to go through the vertex. But if it's more comfortable for you to write the whole thing out or write a longer version than what I said, but still summarized, go ahead. That's just a note-taking skill I want you guys to kind of know. Is sometimes it's okay to summarize things in your own words. This is definitely one of those times. So a lot of times it can be okay to summarize things in your own words. And so this is an example of that. Yep. So once you write that down or write something down for that, your summarized version or that version up there, go ahead and proceed to the back.
Switch colors like this.
Oh, I guess that was back in class.
Yeah, I'm gonna cross that.
No, there's actually nothing on it.
Uh-huh.
10 minutes.
What? Let's shake left hand.
Is that like some
Wait, can I ask
fancy
There it
water?
is.
Just right here.
Yeah, uh-huh.
So there's a bunch of it.
There's actually nothing.
What is it, 10 minutes?
No.
Are you about what? Are you about?
Oh, yeah. No, I'm
Okay, hey, what we're gonna do now requires these things called a compass. Now I'm gonna pass these out. We don't have enough for everybody, so what we're gonna do is we're gonna be in partners for this. We're gonna be in partners for this, okay? So I'm gonna have you guys partner with somebody that's just kind of next to you. So Randall, I'm gonna have you go back behind Emma and partner up with Marley. But otherwise, I'm gonna have you guys partner with the person just sitting right next to you. So Carly will be Max with Max. Gracie will be with Lizzie, and then Sophia, I'm gonna have you go with Mrs. Haswell, okay? Just so we have even numbers. So Mrs. Haswell, I hope you're good participating. Because you are now.
Well, I'm fine.
Okay. So I'm gonna pass out these one to a group. Before I pass these out, guys, these are not toys.
Oh,
Okay? This can be a more hands-on activity, which you don't get a ton of opportunities to do, but it can be a more hands-on activity instead of just straight taking notes for a little bit. Okay? So please, please, please do not play with these, okay? They are very sharp here. Very, very sharp. Like, could very easily hurt somebody. Do not play with them. Is that clear?
why do we use them if they're dangerous?
Okay. They only can be dangerous. Just like a fork can be dangerous, but you use it to eat anything. So it's a good tool for the job, but we just can't be done with it. So,
I have my
That doesn't work out.
oh, okay.
Oh yeah, I have one of those at home.
Oh, we're gonna-
It came out like
Yeah, no, you're
I will.
no. So Randall and Marley are partners.
Me and Randall
And
and
Alicia and Emma are partners. Yeah, that's how it's works.
Will you shake my hand?
Yeah. So, and you're with Max, so yeah. And you're with Lizzie.
Oh.
And then we can do. Let's do you two and you two. And then-
I don't know,
Okay, so you need this and a straight edge. For your straight edge, you can use a ruler, you can use a piece of paper, you can use a phone, you can use all sorts of things. The other day, I was sitting in my friend's car and I needed a straight edge, so I literally just used the side of my phone and called it good. Okay, you can do that if you need, but I'm going to go ahead and pass out rulers, one per group as well.
Wait, what math thing were you doing in your college? Who knows?
I was working through a math worksheet just to make sure that it was good to go.
Thanks.
Okay,
I can call
so with this, I need one back here as well. I got mine for the projector, my projector sized one. So for this, let's walk through how we're going to use this, okay? So I'm going to ask that you listen carefully as we walk through this. Goodness gracious. Whoa, why is this not full screen? Probably. I hope it's still accurate.
You got out of bed and you just like, I don't see anything.
Okay. It's way off.
this big. You go like this.
Oh, wait.
Yours is weird. Yeah, I did that. Oh, I bought my own at Target.
You got your own.
We have ones that have. Yeah, I have ones.
Do you guys have a jacket in the box too?
No, like,
Physically can't do this. I like making
Have you ever had that?
We don't have one.
Okay, let's have a Gracie, watch. Fan size one.
It's a taco thing. I thought it was a burger.
I bet it was Diego Luna. I didn't move it.
Especially tacos.
I can't.
No, we can't do
He's
this.
telling me it's sauce.
Okay, but Kane's opening.
You have Kath-
I
What is it?
forgot about it. Think about it.
It opens
We
the
just need
29th.
to jacket.
Okay. So hopefully this is better now.
Yeah.
Okay, so we're going to practice bisecting a segment.
Did I fix it? So is that supposed to move?
Hey, you're good.
We have moved it.
Pretty well.
This is smarter than you.
So, for this to work, you guys need to pay attention so we can know how to do this. So how yours works, if you can look up here right now, I have one.
I have that one.
This blue one, in a minute. So this blue part is the part that's stationary. This is the part that's stationary. And you can kind of grab it and spin it. Now sometimes when you're doing it, the pencil's supposed to be writing, obviously, it's a pencil. So, you can use this to draw arcs and circles and different things like that, okay? So different circular things. So you can push it, you can pull them further apart by kind of pulling them, or you can push them closer together. Kind of watch up here if you need help doing that, okay? It should go. It didn't actually break, it just came apart a little bit, okay? So if it breaks as it does that, maybe try and kind of grab the actual orange thing together, the actual orange thing, and push those instead. Sometimes that can help a little bit as well. They are sharp. I don't know how many times I said that, buddy. Okay,
Idiot.
so
No, what's the Spanish word again?
okay,
Idiot.
I'll give you another one. Okay, calm down. So how this is going to work is you will put Nathan. Shh. Thank you. So you will put one, Randall. You two. Okay, you will put the blue on a point, and then you will swing through with your pencil. You will what we call swing through with the pencil. So you have yours at different angles, and you will swing through. You want the pencil constantly touching the paper as you do it. Now it's okay. It's okay. I'm just gonna use this as an example. It's okay if you have it not straight up and down, but you have it like leaning a little bit. And as long as both the blue and the pencil are touching, it's going to be okay. So if you need to, instead of having it straight up and down like this, everybody's eyes up here, eyes up here. I see many eyes not here. Carly, eyes up here. Thank you. So it's okay not to have it straight up and down like this. Carly, eyes up here. It's okay not to have it straight up and down like this. You guys can have it at an angle if that helps you draw a better circle and kind of move the angle around. As long as your blue point doesn't move, it won't mess up the circle and what we're doing. Okay, Kennedy, you wanted this one. Randall, what was your question?
Does the pencil be touching the blue dot or what's that letter? Yeah, B dot.
So we'll walk through where we put things, okay? So mine, instead of going to be exactly like yours, I don't have one that size for my projector. I only have one this size for my projector. So what mine's gonna do is this part right here where my thumb is at, where my thumb is going through the circle right now. This will be acting as my blue part, the pointy part that doesn't move, and then this over here will be acting like the pencil. Okay? Kind of follow along with me, please, and thank you. So it says place the compass, that's what this is called. You'll place the blue point of your compass on one of the endpoints of the segment. So I'll take this, and I'll put this on one of the endpoints of the segment. So I'll put it on one of the endpoints. I recommend putting it at the center of the endpoint. So I'm going to put that at the endpoint there. I just picked one of them. I started on the left. Then, choose a setting that is larger than half of the segment. So half the segment would be around here. You want it larger than that. So I can put here, I have a hole here on mine, and I have a hole here on mine here. Those might be good options. I would recommend going somewhere between you want to go somewhere between half and whole. You don't want to go further than the whole. You don't want to go too close to the hole like over here. So I recommend doing somewhere around 3/4.
Right.
I recommend doing somewhere around, if you do somewhere around 3/4, you'll be okay. So go ahead and widen or narrow your compass and the pencil to do that. One person will start doing it, and then they'll hand it and help the other person. And so I want you guys to kind of watch as you guys do it, as the other person do it. If you need to move the desk a bit, that's okay by me.
Which way to
So,
go? I'm gone.
You start it this way, and then you make an arc above and below the segment. So if I choose this setting, I'm going to make an arc above and below the segment. So what I'm actually going to do though, is I think it's easier just to put a pencil, your pencil mark here, and then slide all the way through this whole thing. Now notice as I go, I did not move the blue point. It would have been your blue point. I only moved the pencil. And you go all the way through. When it says make an arc above and below, this is actually easier, I believe, and simpler for us to do, just to swing through all the way there.
Mine touch other words.
So go ahead and try making that. That's okay. So go ahead and try making that. Once again, you need it over half, but not the whole thing.
Wait, over half or like?
And then you can't change your setting for the next one. Your second setting has to be the same as your first. So make sure you keep the setting. Make sure you keep the setting.
What if it's just a tiny bit under half?
It has to be over half. It cannot be less than half.
What?
Okay.
Then how did we do?
Let me see it.
You're triggering me.
So Nathan, watch Kylie as she does it.
No.
Well,
Yeah, I
she
know.
messed up.
Oh. So then, after you do this first one, you have to use the same exact setting. It cannot be narrower. It cannot be wider. It has to be the same exact setting for this to work out. It has to be the same exact setting. So I'm going to come up here, and I'm actually just going to compare the setting just to make sure I have the right one. And then you go to your next point, and you do the other end point, and you do the same thing. Make sure you don't move, and you go through and you make the arc. Kind of. And so as it goes through, it should intersect in two different places. It should make two little, as we'll call them, X's. An X there and an X there. It should make two of those.
Wow, that's 4 jobs.
Okay? It's okay if they're not perfect right now. This is the first time we're doing this. We are learning this process. As we do them more in the future, I think it'll come a little easier
Wait, we're
for
gonna be
us.
using
Back
this
to
more?
the future.
Yes, this won't be the only time we use it. So make sure we're actually using them and learning how to use them.
This is
Okay.
good.
I have
So
some
it's
extra
like-
time set aside today just for the
So
extra
it's
time.
like
that
half
we're
of a
gonna
Venn
use this.
diagram.
How many
Just like the third.
Yes, it's kind of like part of a Venn diagram with the
Look
overlap
at
there.
my
You need the overlap.
I remember in elementary school that one
So,
overlap is-
Raise your hand if you need help or have a question on making our X's, making our overlaps, making our two arcs, okay? I'm going to kind of walk around. Those that I'm seeing so far are looking pretty good. What were we asking?
See?
Let's not do it this
Mine
moment.
like
Okay?
better than yours.
All that stress will
Okay, so they're looking pretty good. Okay, you don't need to make the full circle though, okay? I mean, you can, but you don't have to. I'm happy you're good enough at it, I suppose, but let's not. So, it says repeat using the same compass at the other end point. We did that. So now we're going to connect through these two X's with a straight edge. So I want you to take your straight edge, your ruler, your paper, your folder, your binder, your phone, whatever you want to use as your straight edge. Make sure you line it up and line it up well. Be on there. And you need to connect through it. You want to connect above and below it.
I hate it. Why do you think that?
And I'm actually going to change the color on mine just to make it a little more accented.
Make a line.
Yes.
You do that again.
Yeah.
It'll trigger when you
So,
start messing
You'll go through here, and I'm going to put 1 point on there right now, on the X, and I'm going to line up my straight edge based on that. And then line it up so it goes through my other point, and I'm going to make this line through both intersections. And I'm going to make it above and below, and notice I'm keeping my straight edge solidly in place the whole time. And I'm drawing alongside the straight edge to keep my line straight. Because otherwise, I'm not going to make a straight line. I know me better than that. So I'm not relying on my own skills, I'm relying on my straight edge.
I'm pretty proud of myself.
I'm pretty proud of myself.
I know.
Okay. Right? I hope so. It's weird. Oh, that's pretty neat. So, if we connect these two, what we just made is a perpendicular bisector to the segment AB. The line, segment, ray, whatever you want to call it, I'm going to draw arrows on it to make it a line. The one I made in my red is going to be perpendicular to this as long as we do it well. It's going to be perpendicular, and it's going to be bisecting it. It's going to be exactly in the middle, and it's going to be intersecting at 90 degrees. And it's kind of cool because with the compass and a straight edge, did we use any actual measurements? No, we didn't have to measure the length, we didn't have to measure the angles to get this to happen. You just needed to have the same setting you did the first time and the second time. And it's to be over half but less than full. So do you think that probably I had the same length of my arc as maybe all of you did? No. That's okay, we didn't need the same length of the arcs. Okay, Sophia, what are you asking? Okay, so questions on this process? Okay, we're going to keep practicing this right below here. Okay? So right below here, we're going to construct the three perpendicular sectors of a bisectors of a triangle. So up here, we had one segment, and we did it with the two endpoints of the segment, right? So we did it with one segment. So pretend when we have the triangle, it's just going to be like this one segment, and so we do it with this one segment, just like you would here. On the triangle, we'll still do it just this one segment, where it's over half, but not all. And then you'll do it on this segment. Then you do it on the next, with that one. And then you do it on the next with that one. And they're each separate scenarios. They will each have their own perpendicular bisector. If you're confused about what I just said, try and watch up here to start with. So I'm going to start with having one at the endpoint of one of the segments. If I'm doing this bottom segment first. And I'm going to choose a setting that's over half. This is over half for me. So I'm going to go through, and I'm going to make an arc with not moving my compass on this side. On the very point of this segment. So it's the bottom segment. And I'm going to continue to use the bottom segment as I go over to this side. And I use the same exact setting. I'm going to use my same exact setting and not move my compass and go through here as well. And so this one I just made, I'm going to do this in dark blue. We'll make a perpendicular bisector for only this bottom side. It won't work. It won't be the one for the top, for the left side or the right side, but it'll work for this bottom side. So I'll connect these points. I made two arcs. I put one on this side, one on this endpoint, and one on this endpoint, using the same setting as over half this bottom segment. And that made the perpendicular bisector for this bottom segment. So it would be perpendicular and bisecting it. So if I go again in red, I would now do, say, a different segment. So say I choose the left segment. So I'd go over here, I'd pin it, and I would choose a setting that is over half of this one. So I might not want the same setting I had on the first. You could, but you might not want it. So maybe I now just want this hole over here that's going to be over half, but not whole. And so I make an arc there.
Then would we draw a line to the tiny one?
And then you'll go up here to the other segment, the other endpoint of that segment, and do the arc there as well.
Wait, you use the same folder?
I used the same hole for these two, but I didn't use the same one as I did on these two. So I changed settings.
You have to change up the sign.
You don't have to, as long as it's over half and under the full of that segment. Yes. So, one second real quick. And then, so I would go through, after I make these perpendicular bisectors,
I'm so wrong.
Then you would do that for the other one too?
and then I would do that for the third one too.
I know what you
So it would be perpendicular and bisect here.
Yeah.
So, I want you guys to try this, and I'm going to come around and help you guys. And I would do the same thing for this third side over here as well. And if we do it correctly, all three perpendicular bisectors, my blue lines, should meet at one point. They should all meet at this point below the triangle like this. So if we do it correctly, all of our points should be there. So go ahead and start working. I'm going to come around as people ask. Yes.
I don't know what it is.
Okay. So this first one, so
My neighbor's over
you got
there.
this one, right?
It's rude.
And you put a measurement here. Okay, so right here. Oh, let's see. That's okay, you don't know.
Well, we used them.
Yep.
But you don't use them all the time.
Wait.
So you
No,
don't know what's
which
So this will be about
Okay, then do
the
this.
arc. So it got
That's okay. It's so messy with paper.
So then you go to this other endpoint, you have to use the same setting. Right? And so the setting changed kind of. So you
Just
don't
do
use
it
that.
as
That makes sense? So that's why I typed it up, basically. And so then you'd want it to be between. So you can erase this one, the dark one, the white. Does that make sense?
Both of them?
No, because this one, because I traced over two and it worked.
But no, right there.
Oh, sorry, yes. So,
Now, you do the little line thingy.
yes.
Now I'm gonna be.
Yep, so then you choose this segment, so you let it over half of this segment on the whole. I was thinking, I was gonna say that.
Yeah, my dad has to take that.
It's a problem.
Your mom does, but like, yeah. But like, so that was my first
The other
one.
one's even way messier.
Okay, it's a little not even.
Just chop it,
How do I
put it in
do this?
a water bottle.
Just like.
Next
Give
one,
it the
you
water.
do the same thing.
Good luck, have fun. Do the same thing over here. in
So,
the
yeah,
store.
so,
Yeah.
Like,
The
right?
pointy thing.
so you put it on this
Okay.
one. You
Yeah.
want to do the two endpoints of this thing.
I can't, but it came all the way down here.
So, because this is over half the segment.
That's over half.
So we're good.
Push the guys.
Right? So you go to this endpoint.
How do I end this?
You don't know. You just go all the way through. And so then you use all these, and then you get back to it.
I thought you said it has to connect the one down here.
Oh, no, sorry. So as you use the one, your lines will
Look at how messy my
There's a ruler.
Can't see anything.
Did they do this for long?
So bad.
Yo, Abby, look at how good mine looks. It's just really messy. I just gotta get over how messy it's going to be. It's so messy. I didn't see what's going on.
Can't do the ruler part.
Yo, so you want to play a game called Let's See If This Breaks Cracks Your Screen?
Let's not do that.
It's a pretty good game.
It's pretty cool.
He's like, okay.
$3.
Yeah, that was
What?
$1. No, you're gonna copy it.
Yeah, I don't know.
Is it feet that
I don't know.
Yeah, you got no money with your mom.
Maybe it's probably both.
Where do you work at?
I think it's feet fetish. Yeah, foot
Oh,
fetish.
yeah.
I tried. So I'm just using.
What do you work? You work with your own
Did you say teeth fetish?
That's
Who has
awesome.
teeth like that?
Yeah, I hate
Abby.
Is it a job or is it you face?
What is this? Oh. You use it on the bottom for the sides. Oh, it matches up.
So this one was good, but where are your circles?
Yeah.
Wait, how is yours not
No,
so
but I don't see
messy?
any circles here for
Really
your
messy.
protractor. Here, excuse me.
I did what I could. Right.
So when you
Yeah.
yeah, when you get them, while
That's genius right here.
you're
I'm gonna
okay.
I got nothing.
There is like this.
Look at this. Look at this.
Yeah.
I think I was kidding. Bam, bam, bam.
Okay.
Bam, bam.
You don't have to erase it. You don't have to erase it. Here's the thing. As long as you're there and it's the same measurement, you
Here?
can go right to it.
If I start right here.
See how it ends up being the same now? That's the beauty of it. Now,
Yeah.
okay. So you think you're doing it wrong. What's up? Oh, thank you.
Yeah, I'm gonna go.
Well, now I'm getting to
You say go a little more than halfway?
Yeah, go a little over half. So that one would work, yep. So now you come through and what would you do next? Okay, so which segment, like that, or, so which segment are you working on? I wouldn't say so. You already did the bisector for this one, right? But now you're trying to make this side, right? So you did, so when you did this side, you did this end point and this end point, right? So if you're doing this side, you did this end point, and now you need to do this end point up here. So go ahead and do this end point up here and draw your arcs. And it should intersect with this last one you drew.
No, you have to adjust out.
So,
So if you want like 40 minutes actually.
so then,
Ow.
so then you go where this intersected and this intersected, and you make another line.
And like,
Does that make
I don't
sense?
think so.
And then you would go through and you do the same thing for your
Can I do
last
on the other side?
Yep, so now you go off the place, please.
where did you do the side one at?
Which one?
The side one.
What do you mean the same?
When did you do one?
So like if you were to do this one now,
Yeah.
you would, actually let's do this one, see how it works. What you would do is, just like here, you use these triangles. What?
I don't think that did it.
No, that's- I didn't do those ones, so I'll try to see yours.
So we're gonna do this one. This is gonna be over half. So you were able to without terribly actually for eyeballs. So you go through this result, whatever. Last one, you choose that
You didn't do it?
over half. Yeah, because I had a couple. We'll do the same thing here. Excuse my right. That makes sense, right? Yeah.
How about you do it, right? Mine all has to be different colors, otherwise it follows like circles.
Oh, it's the same job.
Do you want to?
No, I.
It's
Same
awesome.
with Christian.
You have a question.
No, I swear.
I think I did.
No, I didn't know this.
Are you okay?
Oh, okay.
Like, aren't they
Tangerine
like all
Everyone
in?
got CP.
Hey, so let's go ahead and come back up here real quick. Let's come back up here real quick.
Mine looks terrible.
Okay? For sake of time, we're gonna come back up here real quick. So I'm gonna come up here, I'm gonna finish my third one off. I'm gonna finish my third one off. So if I come through, I speed round my third one. Let's focus back up here, please, and thank you.
I did that already. He showed me.
Steam like a bee. Do you not watch Cars? God, I'm done. See, look, it's still not the door.
I'm getting it. So, as you can see, mine ended up intersecting at one point. Now, this is something special where we have, if we draw all three perpendicular bisectors of a triangle, they will always intersect at the same point. As long as we do it correctly, the three perpendicular bisectors of a triangle, which is what we constructed, so this is called construction, will always go through the same exact point. It's a different point for each triangle, but for this triangle, here was our point. So all of ours, if we did it correctly, should have intersected somewhere right around here. Now, we have a name for when we have multiple lines intersecting. So when we have three or more lines that intersect, at the same point, they're called concurrent lines. Concurrent lines. So that prefix con, like conjoin, means that they're like together, right? Or contain. They are together in a container. So that con means together. And current also kind of means at the same place or time. So they are together at the same place. They intersect at the same point. They are together at the same place. They are together, current, same place. Together at the same place or spot. So here, the point of the intersection here of the lines is called the point of concurrency. We call it the point of concurrency. So concurrent lines meet at the point of concurrency, just like lines that intersect meet at the point of intersection. Yeah, no problem. So these meet at what we call the point of concurrency. So here in our drawing, what is the point of concurrency? Point C. Now the question was asked, does it always have to be point C? No, it doesn't. That just happens to be what this was named. This happened to be point C in this one. But it could be whatever point it is. It could be R, S, T, so on and so forth. It could be any point. It just happens to be point C here. So we have this thing where whenever we have three concurrent lines that intersect at the same point, that's what we just had with our perpendicular bisectors, right? We had three lines intersect at the same point. So those lines were concurrent. So we have the special things where when the three perpendicular bisectors meet, they meet at what we call the circumcenter. We have a special name for that called the circumcenter. The circumcenter is where the perpendicular bisectors of the sides of a triangle intersect at a point that is equidistant from the vertices of the triangle. The perpendicular bisectors of the sides of a triangle intersect at a point that is equidistant from the vertices of the triangle. So in this case, the three perpendicular bisectors of this triangle all meet at point P. Point P is what we call our circumcenter. It is a point of concurrency. Those where three lines are concurrent. But here, we specifically call it the circumcenter. And that's because that is where the three perpendicular bisectors meet. It's a special thing for the perpendicular bisectors. And so, we also say the circumcenter, the point where three perpendicular bisectors meet, is equidistant from the vertices. So point P is going to be the same distance to point A, B, and C. It's equidistant from all of those vertices. So that's just kind of a theorem that we have that we're going to use. We're going to go ahead and use that briefly. So if we look at this, example 3, segment KZ, segment LZ, and segment MZ are the perpendicular bisectors of the triangle GHJ. So we have this triangle GHJ, and we have three perpendicular bisectors. So KZ is perpendicular and bisects the triangle at side GH. MZ is perpendicular and bisects the side GJ. And we have side HJ bisected by segment ZL. So just like we constructed the perpendicular bisectors, they are here for us now, given to us. So we can use this given information to find the length of each segment. So if we're told that ZM here, from here to here is 7, we're going to mark that in. We're told that ZJ is 25. And we're told that HK is 20. It is a 7, yes. We're supposed to find ZH and HG. We're supposed to find ZH and HG. Is Does anybody have an idea of how we can find ZH? Sophie, what are you thinking?
Something to do with the 7 and the 20.
Actually not going to be. So hey, let's focus back here on point Z. Point Z is where all three of our perpendicular bisectors meet, correct? So it's called our circumcenter. So we just have this circumcenter theorem that says the circumcenter is equidistant from what? What's that last sentence say? The last part of the sentence say, the last line there. It's equidistant from,
Note that the figure is not
sorry, on the previous page of the circumcenter theorem, excuse me, sorry, should have been more clear. On the previous page, circumcenter theorem, that was on me. So it's equidistant from the vertices of the triangle. So point Z here is going to be the same distance to J as it is to G as it is to H, the vertices. The K and L are not vertexes, or vertices, excuse me. So that means ZH is the same length as ZJ. So that means the measure of ZH is 25. Okay, so the circumcenter Z is our circumcenter, is equidistant to all the vertices. So that means ZJ, ZH, and ZG are all the same length. ZJ is 25, so is ZH. How do we know what HG would be? 20 plus not 25. 20 plus 20. Why plus 20, Marley? Why would this G to K be 20?
Because KG. Oh, sorry, that's Marley.
Okay,
Yes.
fine. Because it's like the little line thing saying that they're the same.
They're congruent because ZK, KZ is a perpendicular bisector. So it bisects this segment. This segment's cut in half at K. If HK is 20, that's half, so the other half must also be 20. So measure of HG is going to be what? 40. You add them together. Questions on that? Okay. We're actually going to jump to the homework now. You didn't get as much work time as
It
I
doesn't
hoped.
have to do with those circle things, right?
It has to do with what?
It has to do with circle things.
Yeah, we're not going to do any construction on there. That was a side project that we did today. But it's going to deal with a lot of the circumcenter stuff. Do you want to listen to instructions that I have after I pass it out again? Because I'm going to reduce it just like I have been. It don't happen every time, but it has been happening a lot lately. Which is kind of nice because you guys enjoy that, I know. I always enjoyed it when it was assignment was short.
I enjoyed it when I was in
That is also very good.
like being silent shortly.
Hey.
Hey, Marley.
It's gonna be short.
Here's the pen.
Hey, Willie. So I have a list of don't do's. I have a list of don't do's. It's a pretty long list of don't do's. So don't do numbers 1, 3, 14 through 17, and 20. So those are the ones I don't want you to do. And don't do 21, but don't cross it out. So don't do 21, but do not cross it out. You can cross out the others, but 21, do not cross 21 out. You don't have to do it, but don't cross it out.
So do it.
You can if you want, but don't cross it out. You don't have. It's not going to be homework, but don't cross it out. Now, when's this homework going to be due? Next class, okay? Hey, what happens if you're struggling and you need help on this? What are some things you can do? Study hall. Ask your friend. Look at your own notes. What else? Are there videos on Google Classroom? Yes, you can also look at the video on Google Classroom, what we did. Okay? So there are some different things that you can use as a resource. You have about 4 minutes if you guys want to get started, or else I'm okay with you guys just having it as free time to relax if you want. You guys can choose. However, I would like for you guys to put the compasses back up here and the rulers back up here, please.